Here we go. So this one over here, we're going to do at the very, very end. I didn't have enough room on the board. So we're talking about trig functions of all sorts of different pieces here. So here's four more that you kind of need to work with and work with enough that you memorize them. But they're the other trig functions. So we did sine and cosine on Friday. It's actually just before this video, but I'm telling you it was Friday. If you're not watching this till Monday. And then, so we have the derivative of tangent, derivative of cotangent, derivative of secant, and the derivative of cosecant. So these are the four derivatives, and I'm going to kind of walk our way through here, and then we'll tackle the cosecant one at the very end. I'll erase all these real quick. So tangent goes with secant here. So tangent and secant, it's secant squared. So it's basically the same idea we were talking about on the last video. Take the derivative of the whole thing times the derivative of the middle. So the derivative of the entire derivative of tangent is secant squared. So I put secant squared u right here. That should say u prime. Okay? And I know that u prime is the derivative of what's inside. So the derivative of what's inside is 5. So when I clean all this up, I get secant squared 5x times 5. And so my derivative is 5 times secant quantity squared 5x. So now, it plugs in nice and neat. Now, I'm going to move the secant here because secant is directly related to secant and tangent. Look at secant and tangent. So the derivative of secant has secant and tangent in there. That's kind of the way I remember it most of the time. Is that if you can memorize this one, you can realize that those two are related almost perfectly, kind of thing. And I don't want to go into any other ideas. Come up with your own ways to memorize them. I put the C's together, those types of different things. So let's just tackle this. So y secant of 5x. Now, again, this thought that keeps coming through with the chain rule. Derivative of the whole thing times the derivative of the inside. So the derivative of the whole thing, which is just secant, is secant u times tangent of u. Secant u times tangent of u times the derivative of what's inside. Derivative of 5x is going to be 5. I didn't do a u substitution for you because I think at this point in the game, get used to not doing that extra work for the smaller ones. Save it for something like this over here that we're going to talk about as we work with u substitution. Now, so I get my secant of u, tangent of u, which is this guy right here in green. Now, from there, I just plug things back in. What was u? U was 5x, so secant of 5x, tangent of 5x times 5, because I got to take the derivative of the inside again. Clean it all up, and we get a y prime of secant 5x, tangent 5x. Okay, so these are kind of straightforward. These the trig identities, not identities, the trig derivatives get a little uglier. There's a few more uglier than this, but we're going to work with them so you guys can kind of remember them. So now, the next example, these are examples on the top of your worksheet, by the way. The next example is y is the cotangent 3x to the 4th power. Now, again, I don't like them written like this, so I redo it so the 4th power is out here, because then I can, that shouldn't have been u prime. I can take this and create an easier looking algebraic equation, if you will, like I said in the last video. So, y equals u to the 4th power if I let u equal cotangent of 3x, and then u prime is the cotangent derivative, which is negative cosecant squared, times the derivative of the inside, which is 3. So, look, we're disregard this. We made u right here. We have u, so we have the derivative of the whole thing, which is cosecant squared, right here. The negative cosecant squared. but I cannot forget the inside. Don't ever forget the inside. It's the most common mistake. Always take the derivative of the inside. So the derivative of 3x is 3. So that 3, you got to make sure it's out here because you got to multiply it. So let's clean it all up. So now remember, this is u prime. So let's take the derivative of u to the 4th power. 4 minus 1 is 3 times u prime because we got to take the derivative of what was there. So now let's clean it all up. 4 times u is cotangent 3x. Cotangent 3x to the 3rd power. So there's this piece right here. And then from there, what's u prime? U prime is this whole thing right here, which is 3 times negative cosecant squared of 3x, okay? So now I've used my u substitution idea when it really counts. This was getting you used to the ideas of it. But you get good enough at it, you can just go, oh yeah, I got to take the derivative of the inside. And when you work with this, you're going to end up doing the same thing. So now I get this piece here. Now I got to plug that whole thing in. And once I plug it in, I just got to do some algebraic cleanup. Remember, calculus isn't that hard. The algebra is. So 3 times 4 gives me my 12. I just took this negative that I have right here. I made sure it went out front. And then I cleaned everything up. Cotangent 3x to the 3rd power is in this quantity. And then cosecant squared to the 3x is inside this quantity. And that is my derivative of the whole thing. Now, real quick, let's see how quick it's going to be. Let's tackle that last example. So I'm going to erase this real quick. And I'll walk you through the thought process because these start getting a little uglier. Hopefully these videos are working out for you guys. So, all right, so let's tackle this. Times it. Oh, it's almost go home time. It's over here. So y equals, I'm going to change it, cosecant 2x quantity cubed. Okay, so now we've got that piece. So I'm going to rewrite this like I did before. So y is going to equal u to the 3rd power if we let u equal cosecant 2x and u prime. Now we got to do u prime. So u prime is a combination of cosecant and cotangent. Okay? So cosecant is going to be negative cosecant of 2x times the cotangent of 2x times the derivative of the inside. Don't forget that 2. Okay? That 2 comes from taking the derivative of the inside. All right. So now let's clean it all up. So we're going to take y prime. We're going to take the derivative of u, which is going to be 3u squared times u prime. And now we just take all our information that we just created and we pull it all together. So my y prime or my dy dx, okay, or my f prime. Don't forget, different ways to write derivative. Pull it together. U is this, cosecant of 2x. So we got 3 times u, not u anymore. U is cosecant 2x squared times this piece, negative cosecant 2x times cotangent of 2x times 2. All right, so remember that 2 is on the outside. It doesn't go with this 2x. So cosecant. All right, so let's clean it all up. It got really big and ugly, and then we got to work it together here. So let's take our coefficients, 3, that negative, and that 2. So that should be negative 6. Let's look for any like things we can multiply together. I've got cosecant of 2x, cosecant of 2x squared. So that's going to clean up to cosecant cubed of 2x. And the final piece of the puzzle is cotangent of 2x. And that should be my answer. And it is. But why does it say 3x? Nah, it's just a typo. So it's 2x. 2x, 2x. All right, guys. That is our plan. Good luck on the trig identities and the trig derivatives, and we will see you soon. All right, video time.